that is called self-generated series. Now see, in self-generated we do not have any definition here, because when it comes to self-generated series, sir, in self-generated my series can behave in two manners. Either my given series could be of perfect cube nature, or my given series could be of perfect square nature, or my given series could be of n cube plus n nature. N cube plus n means the number whose cube I will take, I will add the same number. Or my given series could be of n cube minus n nature. That means the number whose cube I will take, I will subtract the same number, right? Or my given series could be of n square plus n nature, or the given series could be of n square minus n nature. N square plus n nature means the number whose square I will take, I will add the same number, right? N cube minus n means n square minus n means the number whose square I will take, I will subtract the same number, right? Like this. So when it comes to self-generated, my series can behave in these manners. First you copy this, then I will give you example of each and every one. Alright. So now let's write down the example of each and every one. For example, if my given series is of n cube nature, then all the terms written in my series would be perfect cubes like 1, 8, 27, 64, 125, and suppose if next term needs to be found, sir, we can write 1 as to be 1 cube, 8 as to be 2 cube, 27 has to be 3 cube, 64 has to be 4 cube, 125 has to be 5 cube, right? So we are writing these numbers as perfect cubes, right? And we are taking them to be perfect cubes of consecutive numbers. So next this will be 6 cube, right? So it will be 216, right? It will be 216, right? See, I have taken perfect cubes of consecutive numbers, but it would be up to my examiner whether he gives me perfect cubes of consecutive numbers, or he gives me perfect cubes of only even numbers, or he gives me perfect cubes of only odd numbers, perfect cubes of only prime numbers, right? So that my examiner is going to decide, right? But can here my series start with 0? Yes, because we can write 0 as to be 0 cube, right? So here my first term can be 0 as well. Now let's say if my given series is of n cube plus n nature, right? In that case, my terms given would be 2, 10, 30, 68, 130, and suppose if next term needs to be found, we can write 2 has to be 1 cube plus 1, 10 has to be 2 cube plus 2, 30 has to be 3 cube plus 3, 68 has to be 4 cube plus 4. See, the number whose cube I took, I added the same number. The number whose cube I took, I added the same number. The number whose cube I took, I added the same number, right? Similarly, 130 can be written as 5 cube plus 5. The number whose cube we took, we added the same number. So we are taking consecutive numbers. So after 5, the next number will be 6 cube. So it will be 6 cube plus 6, that is 222. 6 cube is 216 plus 6 is 222. Right. Now here, can my series start with 0? Yes, because we can write 0 as to be 0 cube plus 0. Right. Now let's say if my given series is of n cube minus n nature, in that case the terms could be 0, 6, 24, 60, 120, and suppose if next term needs to be found, we can write 0 as to be 1 cube minus 1, the number whose cube we took, we subtracted the same number. We can write 6 as to be 2 cube minus 2, the number whose cube we took, we subtracted the same number. We can write 24 as to be 3 cube minus 3, the number whose cube we took, we subtracted the same number. We can write 60 as to be 4 cube minus 4, the number whose cube we took, we subtracted the same number. We can write 120 as 5 cube minus 5, the number whose cube we took, we subtracted the same number. Right, so we are taking perfect cubes. So we are taking consecutive numbers. So after 5, the next consecutive number will be 6. So it will be 6 cube minus 6, which will be 210. Right. Now here my two consecutive terms can be 0 also, because we can write 0 as to be 0 cube minus 0. Make sure that you copy this, right? All these examples are very important for you. Make sure that you copy them. All right. Now let's say if my given series is of n square nature, right? Then in that case, the terms would be 1, comma 4, comma 9, comma 16, comma 25. And suppose if next term needs to be found, we can write 1 has to be 1 square, 4 has to be 2 square, 9 has to be 3 square, 16 has to be 4 square, 25 has to be 5 square. See, we are taking perfect squares of consecutive numbers, but it will be up to my examiner whether he gives me perfect squares of consecutive numbers or he gives me perfect squares of only even numbers, only odd numbers or only prime numbers. That my examiner is going to decide. But since we have taken perfect cubes of consecutive numbers, after 5 the next consecutive number will be 6. So 6 square, next term will be 36. Now can here my first term be 0? Yes, because we can write 0 has to be 0 square. Alright. Now let's say if my given terms is of n square plus n nature, then in that case the terms written could be 2, comma 6, comma 12, comma 20, right, comma 30. And suppose if next term needs to be found, sir, we can write 2 has to be 1 square plus 1, the number whose square I took, I added the same number. I can write 6 has to be 2 square plus 2, the number whose square I took, I added the same number. I can write 12 has to be 3 square plus 3, the number whose square I took, I added the same number. I can write 20 has to be 4 square plus 4, the number whose square I took, I added the same number. I can write 30 has to be 5 square plus 5, the number whose square I took, I added the same number. So next term will be 6 square plus 6, that is 42. Right? Can here my series start with 0? Yes, because we can write 0 has to be 0 square plus 0. Can my now let's take an example of n square minus n. So here terms could be 0, comma 2, comma 6, comma 9, comma sorry 2, comma 6, comma 12, comma 20. And suppose if next term needs to be found, sir, we can write this 0 has to be 1 square minus 1. See, the number whose square we took, we subtracted the same number. We can write 2 has to be 2 square minus 2, the number whose square we took, we subtracted the same number. We can write 6 has to be 3 square minus 3, the number whose square we took, we subtracted the same number. We can write 12 has to be 4 square minus 4, the number whose square we took, we subtracted the same number. So we can write 20 has to be 5 square minus 5, the number whose square we took, we subtracted the same number. So next would be 6 square minus 6, that is 30. Now in this series, can two consecutive terms be 0? Yes, because we can write 0 has to be 0 square minus 0. Alright, like this. Right. So this is how my series can behave in case of self-generated. So here are the 3 examples for you. Try them. All 3 examples are for you. Try them. I'll wait for a few seconds and then I will tell you the answer. Take your time. Take your time. Think. Right. You should always think before answering. See, the first one is very easy because in my first series, all the given terms are perfect squares and they are perfect squares of even number. We can write 4 has to be perfect square of 2, 16 has to be perfect square of 4, 36 has to be perfect square of 6 and 64 has to be perfect square of 8. So, in my first series, all the given numbers were perfect squares and they were perfect squares of even numbers. So, after 8, the next even number is 10. So, 10 square it will be 100. Next one. See, the next series is a combination of two series which are written in alternate manner, right? So, the first alternate type of series that I see, the first series that I see which is written in alternate manner is a series which is made up of perfect squares, because we can write 4 has to be 2 square, 9 has to be 3 square, 16 has to be 4 square and 25 has to be 5 square. So, these terms they were perfect squares written in alternate manner, and the remaining, right, and the remaining terms which are written in alternate manner, they are in a series which is in the form of n square plus n, because I can write 6 has to be 2 square plus 2, I can write 12 has to be 3 square plus 3, I can write 30 has to be 5 square plus 5. Now, in between 3 square plus 3 and 5 square plus 5, there will be a term 4 square plus 4, which will be 20. All right. Next one was slightly tricky. See, I told you in the last class also, I told you, if you cannot see a pattern within 10 seconds, right, then try your question from the very scratch, right. Try each and every type of series one by one, and if none of the type, and starts discarding them, right. Try with arithmetic. If arithmetic does not make sense, try geometric, try arithmetic or geometrical, like this. So, if you can't see a series within 10 seconds, if you can't observe a particular type of series within 10 seconds, start the question from very scratch, right. See whether the given series is arithmetic or not, geometric or not, arithmetic or geometric or not, like that, right. For example, in this question, as I observe this particular question, I don't see a particular type within 10 seconds. So, what I am going to do, I am going to start my question from very scratch. When I read this series left to right, I see that the terms are increasing, and suppose if this series would have been of arithmetic nature, then there should be an addition factor involved, right. So, addition factor between 7 and 8 is 1, addition factor between 8 and 17 is 9, addition factor between 17 and 42 is 25. Now, if I observe all these addition factors closely, I see that all these addition factors are nothing but perfect squares, because I can write 1 has to be perfect square of 1, 9 has to be perfect square of 3, right, 25 has to be perfect square of 5. So, all these numbers are nothing but perfect squares, right. And now, after 5, the next difference, because these differences are nothing but perfect squares. So, after 5, the next difference should be of 7 square, because all these perfect squares are perfect squares of odd numbers. So, after 5, next odd number is 7. So, 7 square, the term would be 49, right. So, 42 plus 49, it will be 91, and after this next will be 9 square. So, it will be 81. 91 plus 81, will I get 172? Yes, that means I am absolutely correct, right. So if you can't see a particular type within 10 seconds, then start your question from the very scratch. So this is about self-generated. Now after self-generated, the next type of series, the last type of series would be prime number series, right? If the first 5 types, they did not make any sense to you, right? Please observe the numbers closely. It could be a case where the given terms would be prime numbers, right? So the least prime number is 2. After 2 it is 3, then 5, then 7, then 11, then 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97 and so on. I know till 100. If you can somehow memorize till 150, that would be great to you, right? Google it, prime numbers from 100 to 150, and try to memorize them also with these many, right? If you can memorize numbers till 150, it will be great for you, because it is going to help you to solve the questions of classification, as well as it will help you solving the questions of prime number series, also going to help you solving the questions of analogy as well, right? So it will be a great help for you. All right. So these are your 6 types of series that you should know. After learning all these 6 types, now we are going to take some practice questions. See this question, try this question. Take your time. See, if you can't observe a particular type, right, try the question from the very scratch. Because it is not that every time the question is going to take a longer process to find out what particular type of series it is. See, when we were solving that question of self-generated, we started the question from the type of arithmetic, right? But it directly took us to the self-generated type, because it showed me that the addition factors were perfect squares, right? So while starting the question from the very scratch, sometimes it directly takes me to a particular type, that yes, sir, that this series is of this particular type. For example, as I read this question, right, as I read this question, what would come in place of question mark, right? 18, 24, 21, 27. Then next term needs to be found 30 and 27. Now I see that once the series increases, then it decreases, then increases, right? So increase, decrease, it is behaving in alternate manner. So the series could be of mixed nature, right? This is how you should think. The series could be of mixed nature. So now here the difference between 18 and 24 is +6. Difference between 24 and 21 is -3. Difference between 21 and 27 is +6. Now see, +6 -3 +6. Right, so addition factor is behaving in alternate manner, which is constant, +6, right? And subtraction factor, suppose if subtraction factors also behave in alternate manner, so 24 minus 3 it is 21, 27 minus 3 it should be 24. I'm not sure, but to check whether 24 is correct or not, first I have 24 in my option. But to be more sure, right, please be more sure, always be more sure. To be more sure, suppose if this trend continues, plus minus, next it should be plus, and addition factor involved was 6. 24 plus 6, will I get 30? Yes. And 30 minus 3, I'll get 27. Yes. So that means I'm absolutely correct. Right, here factors were behaving in alternate manner, so this was mixed series. Right, in mixed we see alternate pattern. Right.
अब एग्जाम की तैयारी को और बेहतर करने के लिए हमारे चैनल को लाइक, शेयर और सब्सक्राइब करना ना भूलें।